Internal rate of return. It is also one of the modern techniques of the capital budgeting. It considers time value of money. It is the rate of return at which present value of cash inflows are equal with the present value of cash outflows. So that is the internal rate of return. In simple terms, NPV is 0 at this discount rate. So internal rate of return for an investment proposal is the discount rate that equates the present value of expected net cash flows with the initial cash outflows. This is the definition. In simple terms, PV of inflows is equal to PV of outflows, or NPV is 0. PV of inflows minus PV of outflows is equal to 0. This IRR is then compared to criterion rate of return that can be the organization's desired rate of return for evaluating the capital investment. So it is nothing but cost of capital. If we compare with the cost of capital, the internal rate of return should be greater. If internal return is below the cost of capital, then it is not suggestible to accept the project. So, acceptance rules. If the use of IRR as a criterion to accept the capital investment decision, so if IRR is greater than cutoff rate is nothing but cost of capital. So, accept the proposal. If IRR is equal to the cost of capital, the firm is indifferent. If IRR less than cutoff rate, reject the project. So, what are the advantages and limitations of the internal rate of return? This method makes use of the concept of time value of money. All cash flows in the project are considered. Internal rate of return is easier to use. Instantaneous understanding, that is a desirability can be determined by comparing it with the cost of capital. As I told you, we can easily compare with the cost of capital because it is also a rate. Cost of capital we represent in the percentage. It is also internal rate of return. So we can easily compare whether it is more or less. If it is more than the cost of capital, accept the proposal. If it is less than the cost of capital, reject the proposal. So limitations. Calculation process is tedious. So IRR approach creates a peculiar situation if we compare two projects with the two different inflows or outflow patterns. Next one, it is assumed that under this method, all the future cash flows of a proposal are reinvested at a rate equals to the IRR. It is ridiculous to imagine that the same firm has an ability to reinvest the cash flows at a rate equal to IRR means all future cash flows we have to reinvest at the IRR rate. So, a project with a larger fund commitment but lower IRR contributes more in terms of absolute NPV and increases the shareholders' wealth. In such situation, decision based on the IRR criterion may not be the correct. Calculating the IRR. So procedures are different with the pattern of net cash inflows. It is nothing but if cash inflows are uniform, procedure is different. If cash inflows are not in uniform, procedure is different. In these two scenarios, let us discuss about the first scenario when cash inflows are uniform over its life. So, first step, compute approximate payback period. Approximate payback period, also called fake payback period. Fake payback period. And then locate this value in the present value annuity factor table, A4 table, annuity factor table corresponding to the period of life of the project. So whatever the project's life, take that year and search in the A4 table and the present value of annuity factor table so that the value may be falling between two discount rates. So discount cash flows using these two discount rates we have to determine and use following interpolation formula, that is lower rate plus NPV at a lower rate by the difference of NPV between lower rate and higher rate into higher rate minus lower rate. This is the interpolation formula. So lower rate HR represents higher rate. Illustration. A Limited is evaluating a project involving an outlay 1 lakh rupees, annual cash inflows rupees 25,000 for 6 years. So uniformity in nature. Assuming salvage value of the project is 0, determine IRR of the project. So these are the steps we have to follow if it has uniform cash flows. So first step, find an approximation of a payback period. So life 6 years, so 1 lakh. So 1 lakh in how many years we can recover? 1 lakh divided by 25,000. How much? 4 years. So second step. Now find this payback period figure in the present value of annuity factor table. corresponding to 6 years row. 6 years row. So present value of annuity factor table. Interest factor. This one is interest factor table. Interest factor. Present value of interest factor of an annuity. So in 6 years row, we have to find the payback period 4. So 10% has 4.355. Let us go with the 11%. 11% 6 years. See, these are the two annuity factors where payback period, fake payback period fallen between these two interest rate, 12% and 13%. Now we have to calculate the NPVs using these two percentages as the cost of capital. So the value 4 lies between 4.111 and 3.998. Correspondingly, discount rates at 12% and 13% respectively. So NPV at 12 percentage, PV of inflows minus PV of outflows. So PV of inflows, we have uniform cash inflows, 25,000 into what is the discounting factor at 12 percentage? At 12 percentage for 6 years. On 6th year, so it is 4.111. 4.111 minus PV of outflows, nothing but 1 lakh. So NPV is equal to 2,775. Now NPV at 13 percentage, same formula. But here the present value of annuity factor is different. So NPV is negative, minus 50. See, With this, it is confirmed that internal rate of return is more than the 12% but less than the 13%. So, in between these two percentages, NPV is 0. So, that point, that particular rate of return, we have to identify by using this formula to interpolate these two percentages. So, IRR IRR is equal to lower rate 12% plus 2000 NPV at lower rate 2775 divided by NPV at lower rate minus NPV at higher rate. So here it is already in minus, in the sense minus into minus plus. So we have to clearly mention by adding these two 2825. So NPV is 12.98. So 12% is the lower rate. NPV at lower rate is 2775. NPV at lower rate minus NPV at higher rate. NPV at higher rate is minus 50. So minus into minus plus. So it becomes 2825. So higher rate minus lower rate. Higher rate is 13% and lower rate is 12%. 13 minus 12, that is 1. So IRR is 12.98 percentage. So this formula we have to use to interpolate these two percentages. And scenario 2, when the net cash flows are not uniform. So how to calculate the IRR? First step, discount the cash flow at any random rate. Say for example 10% or 15%, 17, 20, randomly. Step 2, if resultant NPV is negative, discount cash flows again by lower discount rate. See, if you use lower discount rate, the NPV will be more. If you use higher discount rate, NPV is less, because discount rate is nothing but a cost of capital. If you increase the cost percentage, the returns NPV represents positive inflows, which is more inflows than outflows. So that if you increase the cost, the inflows will be reduced. So if you decrease the discount rate, then NPV will be positive higher rate. See, conversely, if resultant NPV is positive, positive means more NPV is there, then again discount cash flows by higher rate. If you increase the rate, then NPV will become negative. And then Whenever you find these positive and negative NPVs, just consider those two percentages and interpolate to identify the exact IRR. Okay, so let us go with the illustration. Calculate the internal rate of return of an investment rupees 1 lakh 36,000. This is the cash outflow which yields the following cash inflows: 30,000, 40,000, 60,000, 30,000, and 20,000. So let us discount cash flows by random. That is the first step, by any random rate. Okay, let us consider 10 percentage as a random rate. So at 10 percentage, we have to find the NPV. Compute NPV at 10 percentage. So year 0 inflows are 1 lakh 36,000. So inflows are 30,000, 40,000, 60,000, 30,000, and 20,000. Discount factor for 0 year, it is 1. For the year 1, at 10 percentage, 0.909, 0.826, 0.751, 0.683, and 0.621. We have to multiply the cash flows with the discount factor. So that we'll have present value of cash inflows. So the difference we have to identify whether it is positive or negative. So now it has positive NPV. See, see this one. If resultant NPV is positive, then again discount cash flows by higher discount rate. So 10%, at 10% we have positive. If you increase the percentage, then NPV may become negative. So compute again with a higher rate. With higher rate, let us consider at 13 percentage. So year 0 in cash flows there is no difference because we have to calculate the NPV. So discounting factor for year 1, it will be 1. At 13 percentage, discounting factors are 0.885, 0.783, 0.693, 0.613, and 0.543. We have to multiply the cash flows with the discount factor. So cash flows will be like this. So finally NPV is negative at 13 percentage, but we need a exact discount rate at which NPV is 0. So to interpolate these two percentages, we have to use the formula. So IRR is equal to, we have to represent the You have to substitute all the values. So lower rate is 10% and NPV at lower rate is 2280. NPV at lower rate minus NPV at higher rate. Here it is already in minus, in the sense minus into minus plus. So values will be like this. So 2280 by 2280 minus minus of 7300. So minus into minus plus, it will become 9580. So ultimately 10 plus 0.237 into 2, difference between higher rate and lower rate is 2. So finally IRR is 10.48 percentage. So this is what the procedure we have to apply when the cash flows are not in uniform. Okay, and let us go with the capital rationing concept. This is the another important concept, capital budgeting under capital rationing. As discussed earlier, if project has positive NPV, it should be accepted with an objective of maximization of the wealth of the shareholder. However, there may be a situation due to resource constraint. See, all this concept lies in this sentence only. There may be a situation due to resource constraint. Say for example, if we have only 100 lakhs to invest and there are several projects, various projects, and each project has different investment. So in such a case, which projects do you prefer? Which projects do you ignore? See, if projects are independent of each other and are divisible in nature, so NPV rule should be modified and accordingly projects should be ranked on the basis of NPV per rupee of capital method. If projects are not divisible, in such a case, projects shall be ranked on the basis of absolute NPV and should be mixed up to the point available resources or exhausted. I will give you simple example. You have 100 rupees. Say for example, you want to purchase a pen, book. A pen cost 20 rupees, a book cost um, 50 rupees, and a writing pad cost 30 rupees, and chocolates, a bunch of chocolates costs around 20 rupees. So the total will be 120. So in such a case, how much you have? 100 rupees. So how many projects are there? Four projects, which comes around total investment is 120. So how many projects you are able to afford? Three projects only. Okay. Say for example, I'll just change the amount of the writing pad. Okay. So pen cost 20, book cost 50, 70 rupees, and the writing pad cost is 20 rupees. So 90 rupees it comes. Chocolates, bunch of chocolates, 20 rupees. So total 110. You have only 100. See, here in these two scenarios, if projects are independent of each other and are divisible in nature, if you are able to divide the project, so you can completely invest your 100 rupees in four projects. So 10 rupees in the chocolates, those are divisible projects. So if chocolates are not divisible in nature, okay, so in such a case, how much you are able to invest? 90 only, because the rest of the 10 is not sufficient to invest in the chocolates, because of chocolates is not divisible project. Okay, so likewise we have to rationalize these projects by using the ranking. Okay, we have to rank these projects. Let us go with the illustration. Siva Limited is planning its capital investment program for next year. It has five projects, all of which give a positive NPV at the company cutoff rate 15%. The investment outflows and the present value being as follows. So investment, these are the investments. So NPV, so it is already been calculated. So all NPVs are here and respective investments. Company has a limited capital to spend, that is 1,20,000. You are required to optimize the returns from the package of projects within the capital spending limit, within the limit. The projects are independent each other and are divisible. We can divide and are divisible. So let us rank these projects. Okay. So project A, B, C, D, E. Project A, B, C, D, E. Investments. So these are the respective investments. NPV at 15 percentage. NPV at 15 percentage. Percentage of NPV in investment. How much percentage it has? Because all these projects have different investment capacity. Okay, it has 50 and it has 40. Investment level is different. So that is why we have to calculate the percentage of NPV in investment. So percentages will be 30.8 percentage, 46.75 percentage, and 40.4 percentage, and 37.33 percentage, and 55.14%. So based on these percentages, we'll give ranks. So project E has highest percentage, and then project B, and next place goes to project C, and fourth place is project D, and fifth place is project A. Okay, so if projects are divisible, if projects are divisible, so highest project E, investment how much? 35 percentage, sorry, 35. NPV for that project E, 19.3. Likewise, project B, 40, and its NPV is 18.7. Project C, 25, and its NPV is 10.1. Project D. So in project D, how much you are able to spend? So 35, 40, 75, 75, 80, 90, 100. So you have 120. So still you have 20 to invest in project D. So it occupies 2000 of the project total. It comes around 7.5 NPV. So the total NPV is 55.6 by investing 120. Okay, if you invest 120, you will get 55.6 NPV altogether. Okay, if projects are not divisible, so in how many projects you are able to invest? Those are project E is in top, project B and C. You have to make combinations, E plus B plus, sorry, C, E, B, C, 100. Altogether, you can able to invest 100. Okay, 100 having 48.1 NPV. If you skip project C by inserting project D, because you cannot skip the, you should, you are not able to skip the project E and B because both are in top position. If you want to invest in the project D, so your investment will be 105. So the NPV comes around 49.2. See, even though project D has a lost place, fourth place, still it has a place if you consider its NPV is higher than these three combinations. Okay, so if projects are not divisible, you can able to invest in these two alternatives combinations as well. So this is how we have to calculate the capital rationing.